Okay, guys, lesson 3. The good news about lesson 3, you've had insight into this based on lesson 7.2. Okay? In a way, there's part of me that thinks we should switch around the teaching and do 7.3 before 7.2, but, there's other stuff that impacts that. So, equations. We're talking about separation of variables here. Finding general solutions, and then we'll get to particular solutions. Equations where all x terms can be collected with dx and all y terms with dy are said to be separable. So where you are able to separate the variables. The solution procedure is called separation of variables. That's the name of the lesson. A differential equation will be in the form of dy dx equals f of x times g of y. G of y. To solve, you must put your solution in the form of y equals h of x. Basically, separate the dy and the dx. Move the y's to join the x. Or the y's to join the dy, sorry. I'm not saying this the way I want. Move the x's to the other side. Okay? Our goal is always going to make it y equals in the end. Okay? And then if we can, at some of these, we'll be finding a particular solution. But for this first section, general solution. So, let's practice on some of these. Some of these should be pretty easy at this point based on what we've done the last couple of days. Okay, what would you like to do on A?
Cross multiply.
Okay. Can you think like that?
Yeah.
You can. Technically it's what? Since it's dy divided by dx, I want to multiply by dx. And what I do to one side, do to the other side. Since it's 2x divided by y, we want to multiply by y. Now, with that in mind, okay, on the left, dx's cancel. I'll have
Y dy.
y dy. On the right,
2x cancel.
y's cancel. I have 2x dx. That is cross multiplying, isn't it? That's cross multiplying is a shortcut for what we just did. And remember, you can use cross multiplying when it's a fraction equal to a fraction. Okay? Don't be afraid to. Variables are separated, so now I'm ready to integrate. Integral of y.
1/2 y.
Integral of 2x.
X².
X squared. And then, as I mentioned in the previous lesson, general rule of thumb, you don't need 2 plus c's. Okay, so we don't need a plus c on either side, and it's generally because we're trying to solve for y, we generally put it on the x side. Okay.
Multiply both sides by 2.
Okay, multiply both sides by 2, yes. Hold that thought. I'm not there yet. I want to talk about something else. So then it becomes y squared equals
2x squared plus d.
2x squared. Now, I talked the other day that you don't usually write then a 2c. However, I've seen this done both ways, okay? And that's why I was just looking at my notes to see what she did here. One option is that this is kind of technically a different c, isn't it? And so what I want to show you is that sometimes you'll see the notation of, okay, this was C1. This is C2, not because it's multiplied by 2, but just because it's multiplied by something. So I'm not saying C2 because it's multiplied by 2, just because it's the second C. Okay? I'm not convinced you have to do that, though, but I want you to see different notations. Okay? Now, if we want to solve this for y, so there's 2 ways we could leave this. One option is we could solve this for y, which, as Doug said, you would square root it, and then it's y equals plus or minus the square root of
2x squared plus c.
Plus C2. Yeah, C2.
Oh, Doug, I'm so sorry. I forgot.
Now, that is one option, okay? Another option would have been to not square root it, and if we don't square root it, putting the x squared on the same side as the y squared, and I'm trying to think, I know in mine I have 2x squared minus y squared whoops, equals the C value. Again, it kind of depends on the situation as to what you're trying to do, where you're trying to go. You know, in this, we're just trying to get a general solution. So both are acceptable. Both are good.
So why would it be a positive C2
Again, okay. And again, it's almost like we could call it C3 at that point. Okay? In other words, you don't, how do I want to explain this? You don't necessarily, C just stays C as a constant because here's the deal. Have we plugged anything in or done anything for C yet? No. We have not found C. And so since we have not found C yet, we have that C in there holding the place of some constant that we will eventually find when we are given the information to find. Okay?
Why is it 2x squared minus y?
And, okay, I think just because traditionally you think of x squared coming before y squared.
Okay.
Okay? I don't have a better answer than that.
Okay.
Okay? But it is traditionally what you see. Okay. What else? Did I answer some of the questions?
Did you find out your sub is for tomorrow?
Huh?
Did you find out your sub is for tomorrow?
That's random and
I
totally
know. I was just
unrelated.
thinking about that because I looked over this morning and I was like, oh, right, you won't be here tomorrow.
Okay, let's talk B. What do we do on B?
Multiply dx.
divide by y squared.
Okay. And you guys are good with that at calculus level, yes? That we're going to multiply the dx over, and we're going to divide the y squared over. So then you're going to have dy over y squared equals dx. Is that okay? I always hesitate to do that because like in algebra 2, oh my gosh, that would like lose half the class. But now, what should we think here?
Natural one. Oh,
Nope.
one over y squared.
What'd you say about the y squared? Get out of the denominator. What is y squared out of the denominator?
Y to the negative second.
So think about this as y to the negative second dy equals dx. And why did I want to get it out of the denominator?
Because everything's set to y.
Well, yeah, and I don't want to make the mistake Doug made, right?
Natural one.
Natural log. Only natural log if it's y to the first in the denominator, okay? And common mistake, okay? I say I don't want to make that mistake because it's an easy mistake to make. So, okay, are you ready to integrate? Integral of y to the negative second.
Y to the negative first.
Negative.
Yeah.
Y.
So add 1 to the power. Negative 2 plus 1 is negative 1. Divide by the new power, which dividing by negative 1 is multiplying by negative 1. Equals x plus c. What about that y to the negative first now?
Isn't that just y?
It's one
One
over
over
y.
y.
Negative 1 over y.
Negative 1 over y.
Negative of 1 over y equals x plus c.
So this would be, well, we can't have anything like that. It's not good.
Well, it would,
So then this.
so,
X over y.
okay, I'm getting lost in what all you guys are saying. I just need to solve this for y is what I need to do at this point.
Oh, we're not for y.
We already took the integral. Are you guys trying to integrate again on me, maybe? I don't know what
No.
you guys are trying to do, but all I need to do is solve this for y. Now, if essentially we are multiplying the y over, and then what else do we need to do? Divide the x plus c back. Or, oh no, I don't want to do that. I was going to say think cross products, but never mind. But yeah, I would think multiply the y over, and you divide the x plus c back, so what does that become?
1 over x plus c.
Except it is negative 1 over x plus c. And again, you might run into people that argue a slightly different form there on all of these. Okay? So it's not just one consistent form. Are we good there? Okay, let's try C. dy dx equals xy.
Divide y x from y dx.
So it'd be like dyy or dy over y equals x dx.
There's my natural log y.
Okay, so you guys are good with Kylie and Doug in their first step, yes?
Yeah.
My variables have been separated, so now I'm going to integrate.
Standard Stallion, please report to the high school office. Standard Stallion, please report to the high school office. Thank you.
Must be a middle schooler at this point. Okay, since we are integrating dy over y, this is just y to the first denominator, so
Natural log of 1.
this is natural log of y. Now, didn't we just do something like this?
Somewhere.
It was on board.
Yeah, it was on.
In the homework?
Question number.
I feel like we just did this almost exact problem.
Okay.
So, okay, options here. First of all, we want to solve for y, yes?
Yep.
So remember, this is an e. So you can think left, right, middle. E to the right equals y. So I'm going to write as y equals e to the 1/2 x squared plus c. Now, for whatever reason, you don't usually see it left like that. However, I have this or that. I have this as a possible answer. Okay? Now, what I'm going to say here is that I feel like a lot of the time, this is where you need to be confident in this skill, that you don't see that plus c left here. And so if we think about this a different way, it's e to the 1/2 x squared. And then this plus c is the same thing as saying e to the c, taking the mini steps here. This is familiar from what we did earlier, right? Now, e to the c, though, you won't see that left because that is just some constant. I actually have a k in my notes here because k's and c's are both common constants in calculus.
Well,
So, and again, it's kind of like the whole C1, C2 bit. So like the idea that e to the 1/2 x squared times k, although we traditionally put the k out front, so k e to the 1/2 x squared. Could you use a c if you're hating me for my k's right now? Yes, you can, because I'm getting some hate out there. It is what it is.
on Valentine's Day.
Oh, I'm feeling a little bit of it right now.
Jump to the hate.
Okay, D. 4y, y prime minus 3e to the x equals 0. What do we know? What'd you say? Okay, add the 3e to the x over. Also, what do we know about y prime? So I'm going to rewrite this as 4y dy dx. We add the 3e to the x over, so it's going to equal 3e to the x. Are we there? Yeah, we're there pretty nicely because then multiply the dx over. So 4y dy equals 3e to the x dx. I feel like this one's too easy.
Yeah.
I shouldn't say that though, should I?
2y squared equals 3e to the x.
Yes.
Integral of 4y, add 1 to the power, divide by the new power, which 4 divided by 2 makes it 2. Integral of 3e to the x is 3e to the x plus c. In this case, we're solving for y.
By 2.
So y squared is 3/2 e to the x. And then you could think of this, I have this in my notes as it's a C2 at this point. Okay. Again, I also have seen where people just keep the C constant. So I'm not, going to be too picky there. Now, if we continue solving for y equals
Plus minus square.
plus or minus the square root of 3/2 e to the x plus the c, or c2. That is one option. And again, I'm trying to show you some options here. The other option would have been to do more of a subtraction thing, where you could have written it the 3 e to the x minus 2y squared on one side equals c. It's not a right or wrong thing. It's a different option thing. Okay. 2. Not sure why 2 is separated out, because it's really not a whole lot different, is it?
General solution of the
Cross
difference.
multiply.
Oh,
Okay.
no.
So, you guys have what you need from this screen, right?
I dropped it.
Find the general solution, differential equation. Mario said cross multiply. Are you guys with him?
Yep.
I mean, you're multiplying the dx to one side, the 3y squared to the other side. So 3y squared dy equals the quantity x squared plus 1 times dx.
Yes.
Integrate.
Y cubed equals 1/3 cubed plus x.
Y cubed, 1/3 x cubed, x, and c. Now, okay, again, I have two options here. What was I meaning there? Okay, one option is if you solve this for y, you're going to have what? Cube root of all that jazz. No, you do not. It's a good reminder question. So you have to do plus or minus on square roots or even roots. Square roots, fourth roots, fifth roots, sixth roots, but not cube roots. Not odd roots. Okay, because here's the difference. I can take a cube root of a negative.
Yeah.
Okay, and so when you take the cube root of a positive, you get a positive. When you take the cube root of a negative, you get a negative. So it's not a plus or minus on odd roots. Okay? That's a good Algebra 2 reminder. I mean, that's been a couple of, So,
It feels like forever away.
now, the other option is instead of solving for y, kind of solve for c, I guess, It's, getting it so it's just the terms added and subtracted. With that in mind, though, I would get rid of the fraction. How do we get rid of the fraction? Multiply by 3. So 3y cubed equals x cubed plus 3x plus c, or c2. Okay. And then, so interesting, because see on this one, and I'm just going by what I have in my notes here, if you make it just the c on one side, I actually have, maybe because it's a high power, the 3y cubed first. Okay, so with these c's, we have options here. And that's because we don't know what c is yet. Because we haven't done any work to find c, c is very flexible. Okay? Kind of annoyingly flexible in a way, because we feel like it should be changing with the other things and whatnot, and it doesn't necessarily. Okay.
You stretch this one.
Huh?
That's why you stretch this one.
Wrong. Okay. That was our page of general solutions. Now we've got to talk about our page of particular solutions. 3 examples, but they're a little bit longer. Find the solution of the differential equation that satisfies the given condition. So, your step one, so to speak, is to still separate so that you can integrate, right? So, with that in mind, first of all, what do we know about e to negative t?
Whatever to the D.
Okay, so I'm going to think of this as x over e to the t times dx dt equals 1. Mainly because before I move things around, I need that e to the t to be in its proper location. Now, what would you like to do?
Multiply.
Multiply e to the t and dt? No, the fractions aren't equal to each other. We want to get rid of the denominator of e to the t and the denominator of d to the t. And keep in mind, you can think of this as one fraction, right? I mean, this is, I wrote it as two fractions, but it's one fraction also. Okay, is that better? Okay, so then I'm multiplying by e to the t dt. So x dx equals e to the t dt. I don't know why that's such a tongue twister for me, but man, it is. And then you are ready to integrate. Okay, and as I said, this is kind of, in my notes I have numbers, so this is kind of your step one here. Okay, integral of x is
1/2 x
integral of e to the t.
e to the t plus.
Okay. Step two. Well, okay. It depends on the problem, but step two is to find your c. Sometimes we do it right now, sometimes we do a little solving before we do this. If we're going to find our c next, we have the situation of x of 0 equals 1. What's what there?
T is 0.
T is 0
And y is 0.
and x is 1. Are you seeing that? So the idea that this is the ordered pair 0, 1, where this is a t, comma x. And we know that because it's dx dt. So normally dy dx is an xy ordered pair, right? Dx dt is a tx ordered pair. So in order to find this, we're going to plug our values in. So what do we have here? 1/2 times 1 squared equals e to the 0 plus c. Do some basic math.
Use the 0 as 1.
Anything raised to 0 is 1.
Okay.
I'm not sure if you're telling me or checking, but
Confirming.
confirming. There we go. Like whatever the confirming was that Hannah did earlier that, I don't remember, what was it on now?
Roots.
Cube roots, right, the plus or minus. Okay, did you guys get your C value?
Yep. Make 1/2.
Okay, so, and I kind of solved it without talking because I feel like that's better for you guys sometimes, just do your own solving and make sure you know what you're doing. With this in mind, okay, so, first of all, my general solution, and what form do my general solution was just, what did we have? We had 1/2 x squared equals e to the t plus c. That's general because we don't have the c value in there. When we put that c value in there, okay, and we start talking about the particular, c is what?
1/2.
So 1/2 x squared equals e to the t minus 1/2. Now, there are some fractions in there. And so what could I do?
Multiply the whole thing by 2.
Multiply the whole thing by 2, and then it becomes
X squared equals 2 e to the t
Minus.
minus 1.
-1. Okay? And again, we're trying to solve for x here. That's our y in this situation. You could say x equals and do a square root, or you can also leave it like that and use that as your particular solution. Okay? Questions there?
Maybe we should have chosen brighter colors.
These are pretty bright. These are brighter than normal. Normally, see, I'm in this selection. Normally, I prefer this selection because it's a little more muted. I don't know, not as
Dark.
difficult on the eyes.
Warm colors.
I don't know. Okay, number 4. Find the solution of the differential equation that satisfies the given condition. So basically find your general solution, then find your particular solution. Yes? You don't like this one? We haven't even started.
That's stupid.
Okay,
X,
so
It's okay.
what do we need to do?
I think we can cross multiply it
and then divide the X.
divide the x.
Yes. I see it now. I was like,
Aw. One
Okay, I see what you're saying. My brain was doing it differently, but okay, so you're saying if we go ahead and cross multiply, xy times dy is going to equal 1 plus x dx. Okay. And then that x is on the wrong side. So y dy equals 1 plus x over x dx.
X is
why
Now-
is it not also over dx?
Hmm?
Oh, it doesn't matter. Never mind.
You don't want dx in the denominator. It works out
I
to the
said
denominator.
Yeah, I get it.
Oh, like why I didn't have,
Yeah.
you just don't need to.
It's just like how you put
Yeah.
for logs.
Okay. Huh? No plus c's yet? Oh, no?
Integrate.
It's like you don't have to put it under. Just
Oh, okay. Okay, before we integrate.
Oh man.
Well, okay, or we can go ahead and say we're ready to integrate. But, kind of look ahead. The left integrates fine.
The right doesn't. Also
What do we want to think about the right before we integrate? How can I rewrite that?
1 plus x
one
x
over
to the negative 1.
Not where I was going with it, but that would work but then you'd have to take your x to the negative 1 and you'd have to distribute.
1 over x plus
Plus
1.
what?
plus one.
As in, okay, are you guys saying this?
Split the third.
1 over x plus 1.
Yes.
Sorry, the way you guys said it, I wasn't tracking. Now, side note, Kylie said 1 plus x times x to the negative 1.
That seems harder to integrate now.
Well, but you can't integrate it here. You would multiply, you would distribute x to negative 1,
5.
and then 1 to negative 1, that's going to be a plus 1. Isn't that what we have right here?
Yeah.
Yeah, so same thing. I think it's easier to think this way. I just wanted to clarify. It's not wrong. Okay, now we can integrate. Okay, what do you have?
1/2
1 half y squared.
Okay,
Oh, plus x.
integral of 1 over x is natural log of x. Integral of 1 is x plus c. Now, we have here a general solution, yes? Shall we take it and plug in our particular? What do you know about y of negative 1 equals negative 4?
Isn't that the same as like x of 0 plus 1? It's like
Well, what is it as an ordered pair?
and then 1 negative 4.
Okay, this is the ordered pair, 1 negative 4, and we are taught it's dy dx, so this is xy, right? It's kind of like saying f of 1 equals negative 4, except it's using y. Sorry, I feel like sometimes the hardest thing is figuring out what those numbers are, okay, how they expressed it. Okay, so 1/2 times negative 4 squared equals natural log of 1
Plus 1 plus C.
plus 1
Don't say it.
plus c.
You too. Don't say it.
What is this?
ln of 1 is 0, right?
Yes.
So c is
7.
7 once you get there?
7.
Okay. So now we have c is 7. We have this equation here. So 1/2 y squared equals natural log of x plus x plus 7. Now, what form did I leave it in?
Hopefully that one.
Well, one thing you would do, you probably wouldn't leave 1/2 y squared.
Multiplied by 2.
So one option would be multiplying by 2. Interesting.
No, just leave it.
If we go one more step, there's a good question to talk about here. So, and that would be what? Square root. Plus or minus is what we need to talk about. And here's-
Negative, so it has to be positive. And then absolute value.
No,
Well,
it's more along the lines of based on our original has to satisfy this given condition. And that condition, since y is negative 4, it's the bottom half of something. So it's actually just going to be negative based on the condition we were given. I know, this is an oddity. How often does this happen? It doesn't, okay? But we're only using the negative, and it's because of the 1 negative 4. Okay? Because of the negative 4 there. And if you're ever asked for conditions here, if you look back to this original differential equation,
X cannot equal 0.
and
Y cannot equal 0.
because the denominator cannot equal 0, right? Okay. And again, I'm not going to be a big particular about the restrictions there, but I do have some of that in here. Okay.
Last example, hurry. Go, go, go.
Okay. Find the solution of differential equation that satisfies the given condition. Ooh, this is fun. Okay.
No, thank you.
Direct square root of x over multiply dx.
Okay. And while I'm at it, can I change these to 1/2?
Yes.
Because aren't I going to have to do that anyways? So y to the 1/2 dy dx equals negative x to the 1/2 power. I didn't move my dx over yet, but yes. No, you're good. You're a step ahead of me. It's fine. Good? Okay. Then we are integrating,
2/3 y to the 3 halves.
which I never really showed in my notes, which was weird. Okay. Add 1 to the power. Divide by that new power, which is multiplying by its reciprocal. Add 1 to the power. Divide by the new power, which is multiplying by the reciprocal. And there's a negative out front of that one. And the plus c.
Word pairs 1, 4.
What?
Ordered pair is 1, 4.
Okay, ordered pair is 1, 4. I was debating how I wanted to do this. Okay, you ready then? So, 2/3, what am I putting in for y? 4 to the 3 halves equals, oops, negative 2/3 times x, which is 1 to the 3 halves, plus c. So, can we do this without the calculator now? 4 to the 3 halves. It's the square root of 4 to raised to the 3rd, 8. And so then you're doing 2/3 times 8, which is 16/3, right?
This is just negative 2/3, right?
1 to any power is going to be 1. So that is negative 2/3. And we have a plus c. So c is
6.
okay.
Then can we multiply by 3?
No, c is 18/3, which is 6.
6.
I haven't gone back to the original yet.
Oh.
So now, if I go back to the original, and I'm not sure where, 2/3 y to the 3 halves equals negative 2/3 x to the 3 halves plus 6. I would definitely probably get rid of the 2/3.
Multiply by
3 halves.
We could multiply by 3. We could actually also multiply by 3 halves, since they're both the same, and that would just make our only number over here. So if you multiply by 3 halves, y to the 3 halves equals negative x to the 3 halves. And then, what is 6 times 3 halves?
9.
18 halves, which is 9. How did I leave my answer? For whatever reason. Okay, I didn't mind square roots here, but I did put the y and x on the same side. So, well, when you're going to add it over,
Oh, so x to the 3 halves plus y to the 3 halves equals 9.
that would work. Or instead of fraction exponents, it would be the,
Plus you.
for whatever reason, I have the square root of x to the 3rd plus the square root of y to the 3rd equals 9. I don't know. I know, because then you could simplify that square root. I'm just showing you some options here, okay? There are lots of options, right?
We did it!
Okay. Homework. You have 3 pages of homework
2 pages of notes. For 2 pages of notes.
for 2 pages of notes, yeah. Now, a lot of it is the separation of variables. I will say on the last page, you are finding your general solutions, and then you're trying to match it up with which family it is. So that will be interesting for you. So, hopefully I'll remember to get the answer key available before I leave today. And then,
Text Logan. Not your phone, but
and then 7-4 on Friday.